Good day, viewers. Today, we're going to be learning how to solve this simple exponential equation. Now, I have a video on the introduction of Lambert omega function, how to understand it. So, if you are hearing of Lambert omega function for the first time, please go to the comment section. I'm going to be dropping a link of that video there. So, watch it so you can have a prior idea of this, so as not to be confused later on in this video. Now let's delve in. So the aim of Lambert's function is to solve equations in this format. So to be able to solve this our equation, we have to express this our equation in this form, so as to use Lambert's function. So what this means is that we have to express our equation in this way. We have a variable of a as a coefficient, then times Euler's number e, and a variable of a also as a power equals to a constant or a number. So now let's try that to make our equation like this. So the first thing to do is that let us simplify this using law of indices to express this root in the form of a power. So from the law of indices, this will give us negative a raised to power 1 over a equals what? 4 from the basic law of indices. Now before we continue, you can see that a here is negative, a here is positive, and that's not looking good. So we have to make the two of them either negative or make the two of them either positive. But making the two of them positive is kind of harder. So let's just try to make them negative. So how can we make this a here negative? Very easy. Just multiply the power of both sides by negative 1. So we have negative a raised to power negative 1 times 1 over a equals to 4 raised to power negative 1. Okay, so we can write this as negative a raised to power 1 over negative a equals 4 raised to power negative 1. Now we are making progress. A is negative, a is negative. Yes, these are the stuff we like to see. Now here we have Euler's constant e, but we don't have it in our equation yet. So we ought to introduce it. Now how can we introduce Euler's constant e here? The best way to do it is take the natural logarithm of both sides, the lane of both sides. So that will be lane negative a raised to power 1 over negative a equals lane 4 raised to power negative 1. And from the law of logarithm, this power comes down here. So we have 1 over negative a lane negative a equals negative lane 4. Now we're making progress. To make this a little bit easier, let's express this fraction in index form. So from the law of indices, we can rewrite this as negative a all raised to power negative 1 ln negative a equals negative ln 4. Okay, now we're making progress. We have an isolated variable of a here. Then we can express this as a power of lane using the law of logarithm that says that when you have x, for example, you can express it as a power in the form of 10 raised to power log s base 10. So this log base 10 cancel this, you have s. I've explained that in the previous video. So instead of using log, we're going to use lane, okay, because we have lane here, we're going to use lane. So that will give us, we can write this as e raised to power lane negative a into bracket negative 1 lane 4. But I haven't done anything scary, okay? This negative a, we write it as this. So e can cancel lane. It's still the same to still give us negative a, just like we have here. Now we are making big progress. Now let's write this so as to look more like this. Let's write this coefficient here. So we have lane into bracket negative a, then e raised to power negative 1 will multiply this law of indices, negative lane negative a equals to negative lane 4. Are you following? Now, because of space, let's write this up here. You can see that we're making a very big progress. Our equation is looking very well like this. You can see we're having a variable here, e raised to power that same variable, a variable here, e raised to power that same variable equals to a constant. But we have only one more problem. What is our problem? Can you guess? Nice. The problem is that this power here is negative, but this coefficient here is not negative. and there must be exactly no slight difference. There must be exactly the same t for Lambert function to work. So please, no slight difference. How to bring negative here now is multiplying both sides by -1. Okay, so we have negative ln equals to ln 4, because minus times minus is plus, minus times plus is minus. Finally, you'll see that we have successfully arrived at this format. Now let's make a direct comparison. M here, our own M in this case stands for negative ln negative a. That's our M, right? Then we have Euler's constant E here raised to power m, which is same as our negative ln negative a. Then we have a constant here, which is ln 4. Voila, we can now use Lambert function to get the value of this. So to use Lambert function, we're going to take Lambert function of both sides. Okay, so we have Lambert function of negative ln negative a. Lambert function of ln 4. Ln 4. Are you following? Now, from my previous video, from my introduction video, I told you that Lambert's function always cancels equation of this format, and the result of this will give us this coefficient here. So Lambert's function of this will give us negative ln negative a. Don't forget, Lambert's function of a number like this will give us a specific value, but to eliminate approximation, or rather we continue writing this out. Okay, so we write this as Lambert function of ln 4. So now let us solve for a normally, as we would have done in normal logarithm equation. Okay, multiply both sides by -1 and express this in index form. Okay, ln negative a equals to negative Lambert function of ln 4. We're making progress. Now we have a logarithm here. Don't forget, you can convert a logarithm to indices. Okay, this is what I mean here. Log s base 10 equals 3. So value of x will now be 10 raised to power what? 3. That's the same thing we're going to do here, because ln has a base of e. Here we have negative a will be equals to e raised to power negative Lambert function of ln 4. Now the last thing to do is multiply both sides by -1 to eliminate this minus. Okay, so when we do that, we have a equals negative e raised to power ln 4. Now this is our final answer. So to get a small specific value of this, we're going to input this directly in our calculator. I'll show that on the screen, and I have negative e raised to power negative Lambert function of ln 4 is going to give us negative 0.5. It's negative 0.5. That's our final answer. A equals negative 0.5. If you plug in this into this, we are going to get 4 exactly. I hope you understand this very well. But if you have any question or any confusion or any subtraction or addition, you can include that in the comment section so we can all learn together. So stay tuned. I'm going to be making more videos on exponential equation like this, whereby Lambert function can be of help. So till next time, bye bye.